Hello everyone, a very good morning to all. Dear authors and invited guests, welcome to the technical session 3A. My name is Anisha and I am the moderator of this session. So on behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Competitive Strategies through Zoom. I hope you will enjoy knowledgeable and interactive sessions through the day. In this session, we have 8 presentations and each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. And on 7 minutes, I will raise a gentle reminder. Also, there is a request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, then you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Professor Ruchi Nanda. Dr. Ruchi Nanda is working as an associate professor and research supervisor in the Department of Computer Science and IT at IIS deemed to be University, Jaipur, India. She has actively contributed in teaching and R&D for the last 17 years. She is also a member of the Board of Studies. Her areas of interest and research are in big data, cloud computing, machine learning, and database. She has published and presented a number of papers at national as well as international level. Professor Ruchi Nanda ma'am, welcome to the session.
Thank you, ma'am. Thank you.
Okay, so now we would like to start with the papers, and our first presenter is Muddaluru Charan Teja, and I would like to invite him to present the paper on the title Automated Fish Classification Using Convolutional Neural Networks. Dear presenter, you may please start the presentation.
This is Muddaluru Charantaya. Now I'm presenting the paper about automated fish classification using different convolutional networks. These are my co-authors, and I'm from
department. Open in slideshow view.
Hello.
Hello. Muddaluru, can you please open in slideshow view?
Oh, sure. Fine, ma'am. Hello.
Thank you. Thank you. Yes, you can continue. Yeah.
Today I'm presenting about automated fish classification in different convolutional networks. So this is Charanteja from Department of Information Science Engineering, Rama Institute of Technology, Karnataka, ma'am. So today I will be introducing about these chapters, traditional CNN, also known as convolutional neural networks, and residual networks, also known as ResNet, visual geometry group VGG 16. So DenseNet, known as densely connected convolutional neural networks. See, here a problem statement that we defined is the situations where a fisher or a researcher catches a fish to interrogate about this fish, to know more about this fish. There is a problem. So if any new species were caught by any fishers or marine researchers, normally there are about 34,000 species in the Indian Ocean, which are very unknown to many people. So to get to know more about the fishes, so we introduced this solution for this problem statement. See, there is some background we can discuss about this fish species and their medical properties about the fishes. In many water bodies, there are large number of fishes that we cannot identify. Still, there is research going on among this area. So the research is carried of various fishes were devised. Normally, in the collected data set, we have of 9 different species of data. About each species have 1,000 augmented images. Here, these are the different fish types that we have considered: gillhead bream, red sea bream, sea bass, and red mullet, horse muckle, black sea parrot, striped red mullet, trout, and strip image samples. So each of image of consists of 300 MB. The total set is about of 3GB. This is a description about the dataset and the methodology that we followed here. The dataset is first split into three groups: test dataset, train dataset, and validation dataset. Above this train dataset, we have introduced the model, that is convolution networks and residual network and dense network and VGG. After training, we have used the validator to validate the model. After training model, we have tested the model prediction and classified, and we have recorded the accuracies of that. So when we come discuss about the traditional convolution networks, this is the major advantage for deep learning for classification of different images or image processes. There are certainly many hidden layers and partly connected layers inside the CNN. Typically, the first layer extracts the fundamental features of the edges by using different filters and convolution layers. So more complex images are extracting the main features of images can be advantage for deep learning by using CNN. So here comes the structure of CNN, what we followed here. So normally it consists of layer layers with flattened and a dense layer at top. Normally we ran up to 20 epochs for each image of dimension of 256. So we have used a atom optimizer for updating of weights and shortcut activation function to activate. And yeah, yeah. When we come to the layers, the convolution layer, each of convolution layer consists of pool. Maximum we have used everywhere a max pooling. And after flattening, the dense layer introduced to find the what is a dominating factor and identify the which type of fish it is. So when it comes to results, these are the different results of different species. What have predicted or position, recall, and F1 score of different species. So now coming to a residual network. Commonly, residual network is more advancement of CNN. The major drawback of CNN is if you use more layers, so there is a problem for vanishing gradient. So to overcome this vanishing gradient, residual network is introduced not only for vanishing gradient. There's so many advantages. One of the major advantages is skip correction. So if a point when it comes to the vanishing of gradient, though it uses a skip correction, so that the previous layer can produce the input to the skipping layer. So it's a major advantages of it. And residual networks have so many advantages. It can hold up to more than 50 layers. So when it comes to the architecture of 50 layers, so this is a normal general architecture. So when it comes to 3 into convolution networks, and we'll send it to ReLU function, tail activation function. So if anything vanishing happens, so it will directly skip the layer and take input from the previous layer of that, so that it can reduce this gradient vanishing descent photo. So normally we have used here transfer learning model, which is a pre-trained image from the pre-trained model in ImageNet database, so that we can save time for running different weights and updating. So this is what we can introduce. This is the result what we got from residual neural networks. The precision, recall, and F1 score of different species, around 9 species. Now coming to this VGG. VGG is a runner-up in 2014 ImageNet competition. So it consists of normally 16 layers with flattened with dense layer at the end of after the pooling layer. So here normally we have used same as transfer learning, so which is predefined weights for this. So normally VGG consists of this 16 layers with convolution with these two convolution layers with 1 into 1 pooling layers and followed by 2 into 2 pooling layers. So after achieving by using VGG, after we have achieved these certain results here. So this is 9 species with 9 different results. So by coming to dense network, so this is the major advantage of DenseNet is similar with the rest of network, but there is so much difference between them. Here in DenseNet, each and every layer connected to the each and every layer of both layers, so that it can take image input from different previous different layers when it comes to the gradient binary descent. So when it come to here, every layer is connected to a specific layer without any delay. So all previous layers of future map are dealt with the distance input. So we can take input from previous layer from any point of time when it comes to vanishing out any gradient descent. So it helps to increase the depth of the network with a shorter connection on various layers. Or this is the architecture of denseness. For each and every layer is able to connect with the previous layers with batch normalization and ReLU activation functions. So normally the uh, is a brief introduction of one-to-one dense layers. It similarly connects with everything. After applying, we have used it here to transfer learning to previous normally on stuff running every time. So when it comes to the results, this is the 9 species of different precision, recall, and F1 score of by using dense connection neural networks. So when it comes to the different application and limitations of different convolutional networks, normally everything major application of this every model is to if I image classification here what we have used. See problems are different from different models. So here the problem is vanishing error descent for traditional CNN. So we VGG when it comes to here a similar problem is vanishing error descent, and weighting parameters of model is very heavy due to we're using continuous uh, convolution neural network convolution layers followed by the pooling layer. When it comes to residual networks, the major advantage of this is skip connection. So it will reduce the gradient vanishing descent. So when it comes to the disadvantage, the complexity of the structure may increase, and deeper the usual weakening of training increases. So when it comes to the dense network, dense network is major advantage is similar with rest network. So we can reduce the vanishing gradient descent. And when it comes to the limitations, the major limitation takes more time to run, and it may require the good specification of mission which is running. So these are the comparison of different models what with accuracy. So if we compare with different models, traditional CNN achieved 98.11 of accuracy, and residual network of 99.56, and VG99 dense 98.78. The accuracies which tells us ResNet is 19.56. Maybe it may differ depending on the mission. So when it comes to the conclusion, so we have majorly worked on the 9 species. So we can increase the different species to run over. We can get more kind of classifications. When it comes to the CNN performance, we have accuracy of 98 around with the 5 sequence layers with the rail activation function. Coming to VGG, you have 16 layers about CNN. So about of 99%. When it comes to ResNet, residual network, the overall performance is good compared to the other models. So it comes to 99.6 due to the skip connections and gradient descent. So according to this density, we can say that we have achieved 98.78 accuracy with an 121 layers with dense structure. So we have for except for CNN, for PGG density, we have used a transfer learning model due to the more layers in it. So when compared to CNN, we only have 5 layers. So we have trained by ourselves. This is the conclusion. These are the references what we made, what we referred to the papers. So thank you.
Okay. Can you tell me which data set you have used? You have not mentioned that.
Ma'am, dataset we are normally connected from Kaggle website, ma'am.
Kaggle, but you have not mentioned which data set. Because in the paper, generally it should be mentioned.
Okay,
Right?
okay.
You have mentioned just the data set contain 9 different, because it's not clear whether it's primary data set or secondary data set. Otherwise, your work is very good and impressive.
Okay.
And can you tell me all the photos which you have gathered, which you have taken?
Yeah, sure, ma'am.
Yeah, yeah. They are having same input dimensions as you said,
Yeah, ma'am.
256 by
Yeah, ma'am.
256.
Yes, ma'am. I'll share the dataset once.
Okay, okay. And what factors you have considered for the identification of these fish species? What
Hello,
are the
ma'am.
major factors you have considered
Ma'am,
for the
one of the major
Yeah.
factors we consider is the position, and how many fishes used to have a little different futures, ma'am. So not much different. So we developed this CNN by considering this max pool layer, so it can take a maximum of difference in the after convolution layer, ma'am. So
Okay.
We'll go forward to our next presenter. And I would like to invite Sadhvi Ganuwala to present her paper on the title Down Syndrome Detection Using DCNN. Dear presenter, you can start the presentation now.
Hello, am I audible?
Yes, you're audible.
Okay, I'll just share my screen 1 minute.
Sure.
Hello, is my screen visible?
Yes.
Okay, so I'll start my presentation. Hello and good morning to everyone. The title of my paper is Down Syndrome Detection Using Deep Convolution Neural Network. So my co-participants are Pallavi Shindane, which was our mentor from our college. Next is Sadhvi Ganwala, which is me, Paridhinder Hatnani, Ritika Hemnani, and Arya Telagni. We are from Vivekanand Education Society's Institute of Technology from Mumbai. So the topics that we are going to cover in our presentation, the introduction, the problem statement, the methodology, results, conclusion, and then finally the references. So as we know, Down syndrome is actually a condition in which a child is born with an extra copy of the 21st chromosome. Hence, it also has another name called as trisomy 21. So showing statistics, it shows that 1 in every 1,000 to 11,000 babies are detected with Down syndrome worldwide. It has a high incidence of medical complications, including heart defects, respiratory problems, hearing issues. Early diagnosis for such children is very important as they help them in providing a proper medical health support to benefit the patients in a lifelong emergency cases. Generally, very usual chromosome test known as karyotype test is used, which is used to perform and confirm this diagnosis. But as we know that these tests are expensive, complicated, and are very time consuming. Also, many health remote organizations do not have accessibility to such complex technologies. So, to address the issues, we are presenting our project. The problem statement is that our project aims to address the issue of inaccessibility of proper infrastructures and resources for the parents who are not aware of Down syndrome. The early diagnosis may provide best clinical support to the children for lifetime medical health, which may involve speech therapists, physical exercises, cardiologists, and even neurologists. We have seen that the people who have gained such as Down syndrome is a very sensitive subject, the data set for Down syndrome was not easily, readily available on the internet. So the data set is that we concluded it from the various internet sources which are available and for Down syndrome, and for the normal people, we did use a data set from the CAPWELL. Total 400 images of Down syndrome and normal people were used. The data set which were obtained were then classified into training and testing with a ratio of 7:3. And both the samples of the testing data and the training data included equal subject in order to refrain any bias. Sorry. Moving on towards the next, that is the methodology. In our, as you can see from the flow diagram, that basically the data set which was used was an image data set, which was then pre-processed. Features were extracted. Classification algorithms such as the SVM approach, the name bias approach, and the neural network approach were implemented. The detection performed, and then it was classified into normal people and Down syndrome people. So the major algorithms, the ways which we have used are image classification. That is the convolution neural network. In the image classification, facial points were extracted using the so using the classifiers like the SVM and the naive bias. These this classification used 68 facial points on which the facial was extracted, then fed into the classifiers. The data which was extracted in form of arrays are then plotted to group them into Down syndrome and Down syndrome. But the accuracies for this were very less pertaining to the model that they performed. We moved on to the next part, which is the convolution neural network part. In this, transfer learning models in which already the methods are employed, and we just have to set our input to it, such as VGG16, MobileNet, and ResNet50 were included. But all these are very densely connected networks, which led to overlapping of the features and thus compromise the results and decrease our accuracy. We then decided that we'll obtain our new architecture. So the proposed the deep convolution neural network training involves basically 3 steps. First is the image pre-processing, in which the features, facial photos that were there, which were cropped, and the image resolution of 256 into 256 was extracted. This facial recognition method was then transferred to the Down syndrome identification pipeline. The Down syndrome identification network has 7 learned networks that could be considered as an inception block. An inception block is the one in which all the layers are of different sizes, and thus it simplifies the computational complexity even with the use of few parameters, as we have seen that the data set for our project was very less. So these are the results that we could see. The training, validation, and test accuracies for the VGG, MobileNet, and ResNet, which were the actual transfer learning models, was very less, and the proposed architecture missed an accuracy which is a bit better than this. So is it fine that I show the the implementation too?
No, there is no need to show the implementation. Just give answer to a question that you have used a term that you have created a novel method for the detection of Down syndrome.
Right, ma'am.
I know, but you have used all the algorithms that already exist.
No, actually, ma'am, as the results were very not promising, so we did approach our project in 2 different. That first is the image processing method, and another is the Down syndrome, like the detection method. So the
Right.
image processing was not very promising. We then moved on to the convolution neural network, which provided us better results. But in these, when we use the existing methods, like if we say the VGG16, the ResNet, and the MobileNet, these are very dense neural networks. And as our data set is very less, and when you, if you can see from the data set slide, I'll just show you once.
How many images were there?
Yeah, there were 400 images, and these are the images that we could get from the readily available websites. You could see that even in the non-Down syndrome subjects, there are very similar facial features. For example, if you see the 4th image on this side, it is very similar to that which can provide a Down syndrome result. Because as a baby, the facial features of the Down syndrome and the non-Down syndrome can coincide with each other. So that was the problem, because of which we then have to discover our own neural network. That is why, I have mentioned over here, we use the 7 layers of different configurations, and that led to an inception block. And this inception block was the one which gave us these results.
Okay, fine. Very good presentation. All the best.
Okay, ma'am. Thank you, ma'am.
Thank you for the presentation.
Thank you.
And now moving forward, I would like to invite our next presenter, M. Sudhakar, to present his paper on the title fake news detection approach based on logistic regression in machine learning. So dear presenter, you may please start the presentation. Okay, so M. Sudhakar have not joined the meeting yet. So we will move forward to our next presenter. And I would like to invite Amulya R. Maitri to present her paper on the title Improved Deep Learning Approach for Underwater Image Enhancement. You
Thank
can
so
start the
much.
presentation now.
Yes, ma'am. Am I audible?
Yes, you're audible.
Okay. Thank you so much, ma'am. I'll start sharing my screen. Please let me know if it is.
Okay, it's visible now. Please go ahead.
Okay, ma'am. Thank you. Good morning, everyone, respected session chairs and all the other participants. Today, I'm here to present my topic titled A Deep Learning Approach for Underwater Image Enhancement. This is my project topic, which I have completed under the guidance of Dr. Deepa Abhin. So I'll be covering these topics as a part of my presentation. I'll introduce it, motivation and the objectives which led to the project that I've done. Certain details about the project, that is dataset, model architecture, implementation details, and the results that I've obtained, and the conclusion that we got. So moving on. So exploration is basically the key to any kind of development that we all are aware of. So whatever new is developed or invented, or maybe the improvement of any existing process, is based on the learning and exploration that we have done in the previously. So when we talk about exploring the unknown in underwater, uh, it means that reaching to some depths where we as humans can't go. So for that matter, we have created some underwater vehicles which can do that job for us, namely the automated autonomous underwater vehicles and remotely operated underwater vehicles, which could go to those depths in oceans and seas and get us the information of the life that is available, or that is existing under the sea level. So but then the problem here is that even though the vehicles have best of technologies with regards to the camera and other technologies that they use to capture certain information that is required to understand the life below. So those digitally obtained information could be in the form of images and videos, which are heavily affected by the environmental condition that is present under the sea level. This is because the air domain and the water domain have different qualities, which actually give us the blurry effect, or there are some scattering effects of light that are visible in the images and videos that are obtained from the water domain uh, information. So to overcome that, we got this motivation, and to overcome this particular problem, we have come up with come up with the improvement to a certain architecture that could help us improve the image quality of the underwater images. So the basic objective of my study was to understand what all research work has already been done and how I can contribute in improving any one of them. So that was my main objective behind this project. So the strategy here, as I mentioned, I focused on learning certain deep learning methods, which basically focus on the generative adversarial networks, that is abbreviated as GANs, and I tried to implement some of them and try to improve one of those architectures to obtain more enhanced underwater images. So this is the paper that I focused on and adopted to contribute towards it, because it had a certain scope of improvement, which basically they couldn't overcome with their architecture, and I felt like I could contribute in their architecture to make the images more enhanced. So for this particular project, I have used this dataset, that is underwater image enhancement benchmark dataset, which is consisting 720 training images, 80 validation images, 90 testing images, and in total the whole dataset is of 890 images. All these images have their reference images as well, along with the raw images, because these reference images will be further used in the result calculation for certain um, calculation metrics that we have used further. So about GANs, basically GAN is an architecture of two different neural networks. One is called as the generator and another one is the discriminator. So the generator basically takes the input images, which I have referred as noise here, and it tries to generate some fake images. The discriminator is provided with the actual real data along with the generated images from the generator, and the job of discriminator is basically to identify which of them is real from both the inputs, and it will classify whether the image is real or fake, and this whole process goes on. So basically the idea is that this whole process will improve the overall results. So if suppose I give some fake images from the generator and give the raw images to the discriminator, this will help improve the to get the enhanced images, if we talk in terms of the problem statement here. So the previously proposed GAN that I referred to is called as FUNI, that is Fast Underwater Image Enhancement GAN, which was proposed by the base or paper author. So here their generator GAN is having unit based architecture, and the discriminator is a simple CNN, which is called as patch GAN, Markovian patch GAN, which generates an output of a 16 by 16 image from a 256 by 256 size image. So basically this 16 by 16 image would be the enhanced image here. But the proposed method that we have come up with is that keeping in mind that we have 256 by 256 as the image size, we want to retain the same image size along with improving the image quality. So we suggested the use of UNet for both generator as well as discriminator. So the problem with the discriminator from the base model was that of course the image size, as well as there is limited scope of learning for the generator and discriminator. So because since generator is generating the images that goes to the discriminator, it has limited scope of learning, and it directly gives the classified output. But in case of the UNet-based architecture, what happens is there are two parts in UNet. One is encoder and one is decoder. Encoder basically will give an overall classification for the image, whereas the decoder will classify do the classification per pixel, and it will give the decision pixel wise, which makes the data representation more stronger, and also the task of generator to fool the discriminator becomes more challenging, and hence it helps in generating more enhanced quality data. So these are the implementation details. So as I mentioned, we are using 800 training data images and 90 test images, and we have introduced UNet as a discriminator architecture. Here, because of infrastructure limitation, we were able to train our model for 50 iterations. So for comparison purpose, we have trained both the original architecture as well as our architecture with these same training parameters, and we have compared both the architecture performances with full reference metrics, that is PSNR and SSIM, and non-reference metrics, that is UCIQA and entropy, which are meant specially for underwater image quality checks. So in the images, if we go by qualitative evaluation, you can see this first column is basically the reference images. These are the input images, that is the raw that were captured, and the FUNI, that is the base model, has given these as the enhanced images, and the improved GAN has given these enhanced images. So if there is a slight difference in the visibility and the clarity of these images, and we consider that the fact that these models were trained for limited iterations, the quality of these enhanced images don't really match with the reference images, but we hope that with the increase in the training iterations, this would also improve. So just to give a more clearer view, I have zoomed these output images to basically get a better look of how much difference this improvement has caused. And talking about quantitative evaluation, as I mentioned, we have been using the PSNR and SSIM full reference image quality evaluation metrics, which means that the enhanced images will be compared with the reference images in these evaluation metrics, and these are the results that they have provided us. Similar information is shown in this graphical representation. Another metric that we have used, that is the non-reference image quality evaluation metrics, which is UCIQA and entropy. These basically focus on the image quality and the color of the images that are being produced. So we see that in both the evaluation metrics, we have seen a slight improvement with limited number of iterations here. So we hope that with more iterations, this would improve. To add on this functionality, we also try to have another application check on our enhanced images, which is the object detection application. So if you see the image, this is the enhanced image that is being generated by the FUNI GAN, and there's just one person that is being detected here, whereas in the enhanced image from our improved GAN has detected 2 of the people out of 3 which are present here. So that is the effect of the improvement of this particular GAN. So here the limitation would be that we are still sticking to the 256 by 256 image size, which could be dynamic in real world, and so that could be the future scope for this particular problem statement. And these are the references that I have used. Thank you so much. Any questions?
Very nice presentation. Congratulations. I mean, it's such a informative presentation. You have included all the aspects. You have compared it with the existing algorithm. Now, just come to your conclusion and future scope.
Yes, ma'am.
You have written here that the consistent 256 by 256 image size is a bottleneck.
Yes, ma'am.
Right now, how researchers can perceive this work, pursue this work? What drawbacks you find out in your drawbacks or the limitations you find out in your work, technicalities?
So, ma'am, considering that we could get the digital information from the remotely operated vehicles that we use to capture details from underwater world, so those could have any kind of sizes. We can't actually assume that okay, it will be that much, and when it is used as an input for my architecture, it would be giving the appropriate results. We can't consider that. So if we want to consider the real world usage or the applications and consider the real world problem here, we cannot consider the same image size to be available. So that is the future work that can be considered while making this as a real-time application.
Okay, okay. Very good. Very good. All the best for your work.
Thank you so much, ma'am.
Very good. Yes, next presentation.
Thank you so much for the great presentation.
Thank you, ma'am.
And moving further, I would like to invite our next presenter, Sumit Jain, to present his paper on the title Measuring Impact of Text Features and Image Features on Classifiers Performance for Heterogeneous Data Formats.
Very good morning to all of you. My topic is, my name is Sumit Jain. As a PhD scholar in Sage University, Indore. My guide name is Hare Ram sir, and my topic is, PhD topic, my paper topic is Measuring Impact of Text Features and Image Features on Classifier Performance for Heterogeneous Data Format. Content, abstract, introductions, literature review, image data analysis, literature review about the text data analysis, proposed experimental models, technique for investigations, text feature selection techniques, image feature selections, and classifier are used in SVM and CNN, then result analysis, conclusion, and references. So my abstract is, we design an experimental for demonstrating the effective of different feature selection model for text and image. Social media has become increasingly popular for personal and professional users. Therefore, significant amount of uncontrolled data has contributed by the user of social media. The uncontrolled information may be harmful for some individual or a community. The social media have involved different formats of data, image, audio, video, text. Commonly in social media platforms such as Facebook, Twitter, image and text as a frequently used. So machine learning is provide ability to deal with data for analyzing without manual efforts. Machine learning technique can learn and analyze and learn and recognize, predict or classify the pattern based on their training. Therefore, the proposed work is aimed to craft machine learning framework which can be used for analyzing heterogeneous format of data in social media. The work is motivated to design a framework which will be used for text classification as well as image classifications. Next slide is literature view. Madam, this slide will be shown or not? Hello?
No. Still introduction is visible.
Okay, but
Now literature review.
madam, chalega, yeah, that will be shown just like.
Mhm.
Okay. So this is the first point is image data analysis, and in this case, 5 papers are shown are here. In this, every paper will be show some accuracies point are here only for the image database, and first paper will be show accuracy 99 point something 99.95% accuracy. Second paper image classification, disclosure of image classification, same analyze image. It means in this case we are using some classifier, neural network, CNN, and social media image, high accuracy under event specific and cross events. Second, fourth is image filter, and its accuracy is 0.98. Last one is emotion recognitions. Its accuracy is near about 46.6, then 48% near about. Second one is text data, same case because 5 paper also include in this literature reviews. In this case, some categories text, some features are available, TF-IDF, GA, IG, ML, some methodologies are used, some algorithm are used in this case, and it's in this case, result will be near about accuracy 94%. Second will be short text classification, BBC news data says 0.996. Emotion recognition, it's near about 46.6, 48%. Text classifications, no failure selection method achieved best performance on all criteria. And last one is short-term sentimental F measure 0.847. This is the text data literature reviews now. Now, my next topic is technique for investigation. This is my proposed architecture of this topic now. This proposed architecture, in this case, first text data set. In this case, first component of the data sets. For study the purpose, we use 2 different data set. One for text database and for Twitter social media posts, and second data set is also for the image data set. Both the data set are utilized as an input for the proposed model. Both the data sets are proposed in different manner. First, image data set is pre-processed. Then second will be pre-process of text. We have the different steps for process. Text to make clean. Then processing of text involved for removal stop words and special characters. After making clean the text and image data sets, we have make provision to select suitable features selection techniques, and then combined features. Then we have used 2 popular machine learning classifier for demonstrating impact of feature selection on performance. Thus, after training of the machine learning algorithm, we have used validations set for confirmation the performance. And last one is according to the experiment, we have collect the observation result, and then report will be show in the graph format now. Yeah, this is some text feature selection technique. In this, I have used 3 selection techniques: TF-IDF, information gain, and part of speech tagging text. Term frequency is one of the frequency of the word in a document, and the inverse document frequency is the measure of word across all document. Information gains is for short measure. The reductions is entropy of surprise by splitting a data set according to the given value of randoms. And last one is part of speech. It is the process of converting sentence to form, list of word and list of tuples. The tag in case of a part of speech tag, and significant whether the words is non-objective words, and so on. So these 3 techniques are especially used for the text data for cleaning, and after that we are using the classifier technique. Same case are here, image features selections. 3 techniques, and they also use color features, text features, and shape features. Color feature is used for better stability and insensitive to overcome issue due to the rotations and zoom. It is used in content-based image retrievals. Text features, the local binary pattern is one of the most popular technique for text analysis. And last one is shape features, means vertical and horizontal. And the Sobol operator are used here in this case. So example are here, just image, sample image are here. Picture on which we apply about 2 masks 1 of times. Vertical mask, apply vertical marks on the above sample image. Following image will be obtained. And same case horizontal. After applying horizontal marks on the above sample image, following image will be obtained just like. It's a 2 different way the image will be shown in vertical case and the horizontal case. It will be form on the detection of the line basis now. Next one is classified when after processing it's the text data and the image process data, then we are applying the classifier are used SVM and CNN. SVM is preferred due to the accuracy with less computations, and SVM can be used for both regression and classification. The aim is to discover an hyperplane to classify the data. The differentiate two classes, multiple hyperplanes, and possible among them, we need to conclude hyperplane with maximum margins. SVM algorithm can be used for face recognition, image classification, and text categorizations. Same case in CNN is of the main categories to be image classifications and image recognition in neural network. Scene labeling, object detection, and face recognition are some of the area where conventional neural network are widely used. So this is the result analysis. Result analysis will be in the two parts. First, demonstrate the performance for individual feature selections algorithms, and second is implement for measuring the performance of different combination of feature selection techniques. So first figure, the performance is measured in terms of the times and accuracy. First figure is individual for text data, and in this case, both will be applied here, accuracy and the time section, time and performance for time also. And the same case, image also used, same concept with accuracy and time individually. So in this case, you can see here, IG performance is very, accuracy is very high, and then TF-IFD accuracy is then next IFD next is used, and then after that PSO is used. PSO is especially for the when we are using the analysis part, it means syntactic analysis and executive analysis are used, then we are using the POS functions, or pure methods are used now. And same case also image also. Last one is demonstration the performance classifier with the different feature selection technique combination. Last graph is previous graph is especially for the individual purpose, but in this case we are applying combinations of the features, combination of the techniques. First, TF-IFD plus IGS combinations, that graph will be shown here. Then TF-IFDF plus POS graph will be shown, and then IG plus POS graph, bar graph are shown here. And then last one is IG plus POS plus TFD. When this technique are used in for combined, then graph will be increased now. It will be in between the 92 to 94. It's mean 93% accuracy will be generate. And same case in here, accuracy in case of image, when we are applying the three methods LVP, SO, and plus CG, then it will be accuracy will be near about 85% now. So conclusion, my part is the aim of is to measure influence of the feature selection technique on classification performance in the context. 3 text feature selection technique and 3 image-based feature section technique has been considered. Additionally, for classifying the features, we have used the SVM and CNN. The experiment have been carried out and the experiment result have been collected. Based on the result, we found the individual feature are less effective than hybrid feature in both the case image and text. For text classification, for individual features, information gain provided and higher accuracy, and for image data, Sobel filter is providing higher accuracy result, and the combination of IG, POS, TFA will provide a higher accuracy result, but the time requirement is also increased. In near future, we need to apply some filter to reduce the dimension of combination feature vectors. And same case in case of image vector selection, 2 combination LBP, SO, and CG. And CG and SO is providing similar accuracy, but the first combination is most expensive as compared to CG and SO. So this is the references here, and thank you very much. Any questions?
Yes. Why you have considered only SVM and CNN for your work? Have you tried other?
Yes, madam. Actually, I'm also tried other, but first I'm just tried the SVM and CNN because find out the accuracy, because classifier that this technique is good for that's why I'm using. But I'm also searching one more technique here. In next paper, I will just put it this technique in this next paper also.
What technique you are searching for?
Madam, actually, this is a one. This is a I'm searching related to or reduce the timing and accuracy. Accuracy will be increased and time also. Time will be also reduced now.
And how you have combined the features of text and image?
Actually, sir, madam, actually that's what I am applying. Main reason is that because in social media, so many image and text will be harmful text will be already generated now. That's why we are using both the technique. Actually, some technique, some points where text algorithm is used and some point where image algorithm used. That's why I'm using both technique will be used in one platform now.
Okay, okay. Okay, thank you for
Thank
your
you, thank you, madam. Thank you.
Okay.
Thank you for the great presentation.
Thank you, madam.
And moving forward,
Okay, madam. And can I leave now?
yes, yes,
Thank you.
you can leave now. Moving forward to our next presenter, Kumar P, to present his paper on the title Precise and Accurate Farming Framework Utilizing IoT.
Yeah, are you able to
Dear
hear me, madam?
presenter, yes,
able
you are
to-
audible.
Yes, thank you. I'm
You can
sharing my
start the
screen.
presentation now.
Yeah. Hope you are able to see my screen.
Yes, yes.
Yes, it's visible.
Yeah, thank you. So my title is Precise and Accurate Farming Framework for Utilizing IoT. So we would like to have a very accurate farming with using your IoT devices. So myself, Kumar from Rajalakshmi Engineering College, and my colleague is Vinod Kumar from same institute. So my abstract gives me like agriculture is said to be an important Indian economy where it plays among the top 2 farm producers in the worldwide. And today cultivation uses very traditional methods, which is not effective for present day demand of agriculture products. So we need to go for automation, and automation is going to be very essential in today's day life in terms of agriculture. To automate the agriculture, we need to go for controlling and monitoring the essentials required for the plant crop. It utilizes the different kinds of sensors like dampness to figure the dampness level of the dirt and give the absence of measure of water to the plant. It also provides the temperature sensor used to calculate the environmental temperature, and IR sensor is used for amount of sunlight to be calculated. By limiting the excess amount of essentials, wastage of resources can be avoided. As a result, the accurate growth and harvesting date, profit attained at the date of harvesting, and plant crop can be calculated. With the less amount of effort and less expenditure, we are able to save this particular environment. What are the challenges we are going to face when you do this automation of my agriculture? The efficiency of the farming is influenced by different occasional changes and ecological boundaries, like we are having temperature, sun-based radiation, wind, downpour, and so forth, helpless storerooms, exhausted soil, and helpless information for early distinguishing proof of plant sickness. IoT assumes a significant part of modernizing the farming in India by giving significant and effective strategies to tackling the happening issue in agriculture. IoT plays a very important role, which changes the organization and the effect we are going to have. So some of the related works we have come across is most of the works have been covered with respect of sensor models. And first one, Gaurav Kumar has explained about using a viewing unit, and with the help of the viewing unit, a water can be siphoned and a handoff and a LCD screen, and which is used to regulate the all part of the design. But he has not covered about what is the kind of latest sensor has been used to control the various temperatures. And Karyappa has provided a smart herbicide sprayer robot for effectively spraying herbicides into wheat spaces. But the limitation is in terms of responsible for stable light conditions, which is a framework stumbling block. And Abdullah has proposed a creative and controlled environment creating development that is designed to maintain safe atmosphere in nursery and agri-business settings. But the problem here is the enhancing and decreasing the multifarious nature is not obtained. Flores created a precision agriculture monitoring system that uses the wireless sensor network and Raspberry Pi, which provides the local server to gather the data with minimal effort. But when you go for a central server, on that case, it becomes very useful whenever I'm going to get the weather prediction. And Sadarkar et al. Claims that the sharp marketing subject to IoT advancement will encourage ranchers to reduce the waste and develop appropriateness with the support of various sensors, ranging from the amount of fertilizer employed to soil. But most of the cases, they have not combined all the sensors and they have gone individual atmosphere, and based on that, they are able to obtain a certain result, not the wholeheartedly. So hence we thought about combining many sensors together, and we want to automate the system with the help of the IoT. So the objective of the paper is provide ranchers with real-time data, temperature and soil moisture for climate monitoring, allowing them to improve the overall production and nature of the things. We have used Arduino technology to use in conjunction with the numerous sensors to support the IoT-based smart farming system. The proposed method has resulted in high precision information supervisors of more than 98%. The proposed system is used to utilize the computerized agribusiness by controlling and observing the basic needs of the plant editor. It uses different kinds of sensors, starting from dampness to assign a level of dirt and give the absence of measure of water to the plant, and also uses temperature sensor. It uses the LED sensor to calculate the sunlight, and based on that, it is going to limit the excess amount of essential wastage of resources that can be avoided. As a result, we are able to get accurate growth and harvesting date, profit attained at the date of harvesting. The plant crop can be calculated with less amount of effort and less expenditure using smart and accurate agriculture. So the architecture looks like we are going to use the Arduino system. In the Arduino system, we are going to place the temperature sensor, water level sensor, and soil moisture sensor. And using this, we are able to observe the output in terms of what is the kind of a fan, and then we are able to use the DC motor, and then we are going to have the water pump. So based on the temperature and water level, the water pump is going to activate depending upon the need of the water is required for the particular soil. So it measures the soil level and the water requirement, and all these things can be automated so that the water can be pumped automatically. And when there is an excess of water comes, on that case, the water pump is getting automatically stopped. So how we are going to construct it? So the proposed model can be divided into 3 modules. One is in terms of hardware development kit with the help of the sensors and Arduino. And second one with the help of data analysis. That means we are going to have a centralized server. In that particular centralized server, we are going to have the past data is going to be stored. And depending upon the climate change, it is able to do the activation part. And third one, the application development, where it is going to automate the system. So depending upon the need, the water flow is going to pump from the water is going to pump from the water pump, and then it is going to be flowed. And if there is an water has been reached at level, threshold level, on that case, it is getting stopped automatically. So those things are going to be done with respect to the application development. So the first one is how we are going to use this hardware development kit. So different sorts of sensors and miniature regulators are associated genuinely to screen irrigation applications. So we are going to have the various sensors are going to be placed in the Arduino. And with that, we are able to have the water motor is going to be placed, and then we are going to attach a water sprinklers. Depending upon the temperature level, humidity level, and soil moisture level, the sprinklers are going to get automatically sprinkle the water over the agriculture field. And we are also using a LM35 temperature sensor used to measure the temperature, and soil dampness sensor estimate the water content in the soil and move it to a miniature regulator to make the controlling move of exchanging water siphon on or off. And in this case, we are going to take the input as temperature value, moisture value, and water level value. So this can be measured with respect to the sensor, and based on that, it provides the information to the hardware kit. And it collects this particular information, and then depending upon the requirements set up by the user, it is going to sprinkle the water over the field. So next second part is on data analysis. So here data is collected from the previous history, like time, date, month, and years, based on the temperature level, moisture level, pH, and humidity, light intensity sensors are given as an input. So based on the past data, it processes the performance of data analysis is done by collecting the data from the input values, and it is now compared with the given values for instruction as the output. The data analysis provides the details of resources to be used and limited accurate data of harvesting and accurate profit yield on harvesting. It makes the climate more acute by the joining sweat, cultivating, market insight, and IoT innovation. The crucial job is to make precision in terms of how we are able to sprinkle the water and how we can make the expenditure less, and how we can go for in terms of increasing the time. In the third part is on application development. So in the application development, the application is built with respect to the precise agriculture assist the rancher with observing the temperature, dampness, light force, which are all valuable and proficient dynamic for yielding high efficiency. It additionally gives the specific insights regarding the harvest development and the measure of development to be developed when the development utilizes a portable application, which will be simple for the rancher. We use inputs like zeros and ones for microcontroller, and the data analysis are given as an input for developing the application. The application calculates data given and process the data in the mobile handset. So we are able to visualize the output in the mobile also. And initially the code is designed based on the user expectation and the kit is developed. Mobile application is developed using the Android platform. The collected data and the processed data are displayed on the mobile handset. So the results and discussion. So based on the construction of the 3 models, we are able to automate the agriculture by controlling and monitoring the essentials required for the plant crop. The system uses the different sensors for identifying the temperature and then moisture and then how the water can be sprinkled. The moisture sensor used to calculate the moisture level of the soil using the threshold value of the sensor and to provide the plant with necessary amount of water. The temperature sensor is used to calculate the ambient temperature, and sunlight sensor used to calculate the amount of sunlight. With the help of the breadboard, these sensors are connected to the microcontroller. The Arduino Uno is a microcontroller utilized in this paper. The moisture sensor is put on the soil, and the amount of electric resistance in the soil is used to calculate the amount of moisture present in the soil. The water pump is connected to the Arduino for smart irrigation. At the point when the dampness is low and the limit esteemed from the sensor is underneath in excess of 970 liters, the Arduino teaches the water siphon to get turned on. And when the water level is high and the edge streamed from the dampness sensor is under 970, the siphon gets turned off because of the great measure of water content. The instructions are given as per the data analysis with the previously corrected details. From the results, we have obtained that the expenditure before we apply using the sensor, the expenditure is going to be reduced and the wastage is also going to be reduced. And then we are able to harvest rate has been increased and the profit also been increased from the existing system. So the expenditure has been increased. The expenditure of the existing system is 50% earlier, and now it has been to 40%, and the wastage is 20%. Now the corresponding wastage is 10%. The harvest rate is 80% and current harvest rate is 90%. And the profit is also reduced to from the 30%, it has been increased to 40%. So hence we say that the profit rate is comparatively high in the proposed system than in the existing system, as the expenditure is low as 10% and the wastage is low as 10%. The benefit increments as 20% extra in proposed framework when contrasted with the current framework. Subsequently, the proposed framework is more productive in diminishing the wastage and consumption to expand the benefit rate. Hence, we conclude that the proposed framework gives the specific insight concerning the yield development, and the smart agribusiness versatile application is created to screen the development of the harvest. It also uses the remote sensor networks are sent to the portable application through Bluetooth module, and this will save time, cash, exertion, and it will be valuable for the ranchers, that is for the farmers. As a future work, this can be loosened up by adding a robot which can be used on the field practices for water framework issues and limit the issues using inaccessible control robot, canny water framework system, and a splendid stockroom, the leader structure independently. And some of the references we have provided here. And next one, we'll move on to questions, Jenny.
Yes, sir. Thank you for your presentation. You have presented a very interesting topic as far as precision agriculture is concerned. Definitely, it's a added advantage for the researchers who are, taking care of this field. Is it a part of some project or?
Hello.
Hello.
Yeah, just go
Is
ahead.
it a part of some project or?
No, it's we are working on a particular project actually.
Okay,
As a
okay.
part of a project, we have been developing this particular work.
Okay, okay. So you have taken some project from DST or somewhere?
No, we are doing as a final year students project, and then we are also having a fertilizer farmers, and we are just helping them to do this particular project and test it how best it can be utilized.
Okay, okay, okay. Right. Okay, thank you.
Thank you, ma'am. Thank you. Can I leave?
Yes, all the best.
Thank you for the great presentation. And moving forward to our next presenter, Pradeep Kumar Juneja, to present his paper on the title. Someone's audio is on. Can you please mute the audio? Yes. So I would like to invite Pradeep Kumar Juneja to present his paper on the title Time Delay Approximation Effect on Open Loop Performance of a Delayed Industrial Process Model. Dear presenter, you can start the presentation now.
Okay, ma'am. Thank you for introducing me. I'm just sharing the slides. Is it visible now?
Yes, it's visible.
Okay,
Please go ahead.
so I'll just start with slideshow. So actually, this is a work related to paper industry where consistency control is very important to control, and this is many of the processes have inherent dead time in the industry. The presence of dead times leads to challenges in controlling the process. The design of controller becomes very challenging for this, especially for multivariable systems, for time delayed system. So there is an approximation techniques available. We have used payday approximation technique to approximate the dead time so that its effect can be compensated. And in this analysis, approximation is performed for various orders for the selected first order delayed process, which is for headbox consistency process control. And then the performance of achieved from various techniques, various orders of approximations have been compared and some conclusions have been drawn. Chemical industry process, which includes textile, pulp and paper, water purification, sugar mill, leather industry, cement industry, fertilizers, and many more. Just to name a few of the chemical industries, our work mainly focuses on paper industry and sugar industry, where many processes are common, such as evaporation, lime kiln process, and so on. So many industrial process in process control can be analyzed with the help of the model of the process because actual process transfer function is not known. Identification techniques are very difficult. And here dead time comes naturally in the process model where energy propagates from one place to another. So presence of dead time is very common in these industries. And most of the process can be modeled with the help of FOPDT model, which is first order plus delayed time model. So this is process flow in the paper machine in a paper industry where raw material is sent to the pulping section, and then from there it is sent to screening. Then pulp washing is done, which is not only sent to bleaching but also liquid evaporator, and then to liquid burning and liquid causticization happens in the lime kiln. Here, after bleaching, screening, stock preparation, and finally the paper machine gets the paper. So this is the time delay approximation of payday, where in this slide we have shown just two payday approximations up to second order only, whereas these expressions becomes very complex in case of third, fifth, and 20th. It is beyond you know beyond simplicity. It is very difficult to write even though that expression in one slide if we talk about very high order approximations. So this is the proposed approach where we have selected a model which is an actual model from the industry, from the paper industry, corresponding to the headbox consistency. And here we have performed the delay approximation with various orders, first, second, fifth, 20th, 15th, and then we have obtained the step responses for transfer functions for all the orders. And then we have compared all the responses and we have deduced important conclusions from there. This is a transfer function which we have selected, which is given by Nancy, where GPS is 0.03. This is a process gain 0.03 e power minus 5s, where exponential delay is of 5 seconds, and then 1 plus 10s, where 10 is the time constant. So this is a typical first order process along with the presence of delay. As you already said, that delay is an integral part of any process in chemical industries. So here delay is especially because of the far location of sensor. So in this slide, we are just showing that the actual process is represented, step response for the actual process is represented by blue graph and a curve, and then green curve represents the same transfer function, which is modeled with the help of first order approximation technique of the payday. And we can see this is very close to each other. Then this is a comparison between first and fifth order approximations of the payday. Actual process we have skipped here. First order and fifth order are also very near, and then fifth and 15th are nearly the same. As you can see, fifth order approximation and 15th order approximations in the response wise, these are nearly the same, but the 15th order payday approximation is very complex in nature. Very complex mathematical expressions exist for 15th order payday approximation. And finally, we have compared for first and 15th. There is some discrepancy, but that is also a small change. Small differences exist between first and 15th. So in the form of 15 and 20 are exactly same. We can see for the selected process, payday approximation of 15th order, 20th order entirely covers the responses of each other. So we can compare these in the form of this table, where we can say that out of these two characteristic, one is rise time, which is an important transient characteristic of the response, and settling time, which is also in seconds and which is an important steady state response characteristics. If we compare these two, then when the original process, which has no approximation has been done, the values are 22 and 44.1, whereas if we go for first order approximations, the values are as shown. But as we go up to the higher order, let us say 15th order or fifth order, the values are now entirely the same, exactly the same, although these are resemble with each other, but these are very close to each other. So this column represents what is the percentage difference between these values, and we realize that as we achieve fifth order approximation, so the values are same after that. So important conclusions can be drawn that there is no need for going for higher order, very high order approximations, because what we think actually is that if we go for higher order approximation, it will be more approximate, but that will be a wastage of efforts, because the values are not changing after fifth order approximation. So this conclusion, which we have just discussed, can be again that the step response achieved in case of fifth order payday approximation is very similar to the original transfer function. So there is no use of further approximations to higher levels, as it will increase the complexity in terms of mathematical expressions and does not increase the accuracy. Accuracy remains same as we have got in the fifth order approximation. So these are a few references. Thanks. Now I'm ready for queries. Yeah.
As per your presentation, then it is can we conclude that 3 to 4 approximations are required?
Yes,
Because
ma'am.
after fifth, so we can say the higher order is
Yes,
starting.
ma'am. This is very easy up
Yeah.
to third approximation, and up to fifth also this is okay. Mathematical analysis to get that approximation formula, it is okay. But after that, we have to take the help of some software.
Okay.
Ha,
For
and
calculating these approximations, which tool you have used?
I have used MATLAB Simulink.
Okay.
Yes,
Okay.
MATLAB control system tool of MATLAB.
Okay. Okay.
Yes, ma'am.
Okay. Thank you for your presentation. All
Thank
the
you,
best
ma'am,
for
for
your
the patience listening. Thank you, giving me chance. Thank you, ma'am.
Thank you for the great presentation.
Thank you, ma'am.
And now I would like to invite our next presenter, Soham Bhattacharya, to present his paper on the title Towards GPU Accelerated Computation for Stock Prediction Based on News Headlines. Dear presenter,
Yes,
you
ma'am.
can
Good
start
morning,
the
ma'am.
presentation now. Good
Good
morning.
morning, ma'am. Can you hear me, ma'am?
Yes, you are
Yes.
audible.
I'll share my screen.
Okay.
I hope you can see my screen, ma'am.
Yes, it's visible. Please go ahead.
Okay. So I'm Som Bhattacharya. I'm going to present on our paper titled Towards GPU Accelerated Computation for Stock Market Prediction based on news headlines. So opening with our research motivation, stock market movement has the potential to tell the future worth of a company's stock. The foresight of a stock's future price is very crucial as it could yield significant profit. And this field engages disciplines such as statistics, programming, data science, etc. The trend of changing stock prices every minute depends on many factors. A significant influencer of the stock market is the sentiment of investors about the stocks of a specific company. Now, to form an opinion on stock market investments, news is inarguably an important source to draw the relevant information from. More than complete news articles, news headlines offer a quicker way to sway the sentiment of investors. In recent times, parallel computing has become an extremely important principle, helping us to achieve better computation. Stock market analysis similarly requires continuous monitoring of stock prices and real-world news before making predictions. The sheer amount of data that needs to be processed can make the computation extremely slow in single-core architectures. So we have tried to use the GPU, or the graphics processing unit, for processing, as quite often the CPU can be overwhelmed with system processes. Platforms such as Google Colab and Saturn Cloud enable the use of high memory multi-core GPU, some of which have been used for this proposed work for parallelizing. In this paper, models have been separately trained and news sources scraped from the internet with the vision to marry the two and predict real-time stock movement based on news articles or headlines. Additionally, we have also presented optimum ways to extract sentiments from such live news headlines. This is the proposed architecture of the technical procedure we followed in this research paper. There are two major parts, one that involves fully fledged machine learning and another that consists of scraping relevant stock news headlines from the internet, extracting the sentiments in terms of positive, negative, or neutral, and finally comparing them for individual tickers, that is basically codes for companies, like 3-letter or 4-letter codes, over the available period of days when the news articles were published. So there are details to be explained in later slides. So the GitHub repository that has been linked here contains the data set that was utilized in this paper. There was a considerable amount of pre-processing to be done on the data sets for usability purposes. For example, the CSV file containing daily stock information of Google is shown here. There is similarly data on other companies such as Boeing and Walmart, which is not shown here. The open and close columns had to be taken into account to derive 3 variables, which will be shown in the following slide. So in the processed and cleaned data set, the 3 major variables that were obtained were percentage increase, label, and binary label. Binary label contained only up or down, corresponding to the direction of stock movement in a specific company over the course of a specific day. Label had one more category named same, which approximated a 0.3% change in stock price to mean no price change at all. Further, the news headlines of the same dates were arranged in the same row, with each cell in the row containing a news headline, up to 12 headlines per date. So for each date, thus we had a collection of 12 headlines or less, and the corresponding label of stock movement for the date. After the pre-processing, we were left with 6,000 data rows. This is a comprehensive summary of the models that were tested. Before going for neural network based models, we tested with models like k-nearest neighbors, random forest, XGBoost, and logistic regression, because most of them are parallelizable as well as very popular for NLP based models. Along with the models, there were other parameters, namely the processing environment that includes CPU, GPU, and TPU. TPU is for tensor processing unit. The type of label used, that is whether 2 class or 3 class. 3 class, as in it included the label named same. Then there was the pre-processing algorithm, the vectorization algorithm, the validation accuracy obtained, and the optimal number of processes. The maximum number of cores available for CPU environment at a point was 8. The best non-neural network accuracy obtained was with KNN classifier on binary labels and TF-IDF vectorization. TF-IDF is a standard vectorizer that considers the term frequency and inverted document frequency of each token in a dataset. BERT stands for bidirectional encoder representations from transformers, a deep learning model which helps computers to understand the meaning of ambiguous language in text by using surrounding text to establish context. So here BERT was trained using a Python library called K-train. K-train has the ability to train the model across multiple GPUs in a distributed fashion. But due to lack of resources, we were able to train the BERT model on a single GPU at the maximum. However, we implemented the multiple GPU training procedure anyway, so that if given the resources, we could make the most out of it. Training the BERT model on CPU took a rather long time, almost around 5 to 6 hours, whereas training on GPU took roughly between 20 to 30 minutes. As can be seen in this accuracy loss curve, the model is almost negligibly overfitted towards the tail end of the graph. That is concluded from the slope being nearly parallel to the x-axis. The more parallel it is, the less overfitting there is. This can be further improved with a larger data set. So this is a screenshot of the root site at finviz.com, which was used for the web scraping. Each ticker that you can see corresponds to a separate company having embedded outlinks to a list of headlines related to the specific company over a period of days. For example, on the left is a screenshot of the page containing the headlines of the company corresponding to the ticker AHPI, which happens to be Allied Healthcare Products Incorporated. Each such headline can be scraped with date and ticker, and the dataset thus obtained can be used to test the model we trained. The screenshot on the right depicts a sample of the data frame obtained after scraping. The maxpool module of Python was used to parallelize the scraper workers on multiple processors. The CPU at our disposal had 2 physical cores with 2 more available due to hyperthreading. It was observed that a single process of scraping took more than 10 times the amount of time taken by 4 processes running in parallel. After this, as a separate feature of this paper, the sentiment of each headline on each day was extracted using a pre-built model called Flare. Sequentially executed, it took around 113 seconds for processing every daily consolidated headline for a sample company such as A.O. Smith here. However, using job-libs multiprocessing and distributing the sentiment extraction between 4 cores, it took 85 seconds. Here, the length of each green bar is proportional to the total positive sentiment on a day, while for red, the negative sentiment is proportional. The prediction of stock movement direction for every headline was done separately in a loop on the GPU environment, which took about 207 seconds. This, when tried on the CPU environment, took too much time to be completed. However, when predictions were made on headlines concerning a specific company, it took considerably less time every time, which was less than 60 seconds. Here, the length of the green bars are proportional to the possibility of there being upward stock movement on a day based on that day's headlines. The red bars are similar in depicting downward stock movement on a specific day. Here, American Airlines has been considered for the news. So as for the conclusion, we achieved an accuracy that was about 99%. Without compromising on fitting, that is, it was neither underfit nor very considerably overfit. And it was more than the average accuracy on similar papers, which was an average of 70%. Using BERT to predict the direction of stock movement is an important feature of this paper. There were multiple models, techniques, and algorithms that were comprehensively compared based on various parameters such as number of cores for parallelizing and pre-processing techniques, etc. There is also a rudimentary use case with web scraping that uses parallelization, which has been demonstrated wherein live headlines are scraped and tested against the model. There are some drawbacks, as in some scope for future improvement, such as we could have, like there can be instances where a larger data set can be used, and even the negligible amount of overfitting can be removed. And other cases such as like studying the effect of news on the stock, but on the next day instead of on the same day. So these are the references that these are the papers that we referred for making the research paper. Thank you.
How much data set you have taken? What was the size?
Ma'am, it was after pre-processing, it came down to 6,000 rows.
Okay. And which web scraping tool you have used in Python?
Ma'am, Beautiful Soup we
library?
have used. Ma'am, Beautiful Soup.
Okay, okay, okay. Okay, fine. All the best.
Thank you.
Next. How many presenters are left now?
Okay, ma'am, we have completed all the presentations now.
Okay, okay, okay.
Yes. So now I sincerely thank all the authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 6th version of the conference, and we will be happy to have you in the 8th version in 2023. Moreover, all the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Springer. The publication will be live within 6 months. So kindly cooperate with the team of ICTCS 2022. I would also like to thank our session chair for chairing the session. Here is a small token of appreciation on behalf of the team ICTCS and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Thank you, all of you. Thank you, GR team, for inviting me as a session chair in this conference. And it was very, very informative session. All the presenters very well presented their ideas, their research work. Overall, it was very, very informative, and all the aspects, all the areas which are covered in machine learning, especially, they are presented in the session, like automated fish classification, right from the disease prediction to fake news detection, web scraping, IoT-based research papers. So overall, the session was very, very informative. Thank you all.
Okay, thank you so much, ma'am, for your kind words. And now, as we have come to an end of the session, I would request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.
Thank you all.
Thank you, ma'am.